All right, so we're finishing up yesterday's worksheet, and then homework tonight is going to be that law of cosines worksheet I left you guys. There's two questions on the front, law of sines. That's for you guys to finish, and then watch the videos on the back for each question and go ahead and do that. We'll go over those on Monday. Okay, so number one, we want to figure out the length of y here in simplest radical form. Okay. So we're going to try to use our rules for 45, 45, 90 right triangles. Remember, you guys did this yesterday. Okay, remember the rule. If this side is x, this side is x, the hypotenuse has a length of x radical 2. All right. Now, the way I remember this usually is that there's two equal angles and two equal sides. So I'm using radical 2. Two equal angles, two equal sides, radical 2. Okay, and a 30, 60, 90 right triangle. Okay, it's got a 3 for 30 and a radical 3. So keep that in mind as you're working along here. All right, so this is how we're going to show our work. We're going to label things. So if this is y, okay, then this side is y, and this is supposed to be y radical 2. So I'm labeling it with the pattern, and then I'm going to create an equation and solve. So that means that y radical 2 is supposed to equal 18, and I'll solve for y by dividing by radical 2. Now we have a problem here. Simplest radical form technically also means not only is there's no perfect square factors in the radical, like 2 can't break down, but I also can't have a radical in the denominator. The only way to get rid of a radical is by squaring it. So I have to do what's called rationalizing a denominator, which means I just multiply. Right now, radical 2 is rational. We want to make it rational. That's why it's called rationalizing. So I have to square it, which means I have to multiply it by itself. Okay? But I can't just multiply the bottom by radical 2. I have to multiply the top. All right? So radical 2 times radical 2, you guys remember, is just straight up 2. That's square root of 4, which is 2. That's on the bottom. And the top becomes 18 times the square root of 2. And then I'm just going to reduce the 18 and the 2 here. So we can take a 2 out of both, write factors into both, divides in, and I get an answer of 9 square root of 2. Now, if you don't, I don't remember how to do this, having a bad time with it, also remember that you can use Pythagorean Theorem here, okay? Y squared plus y squared equals 18. And then we're just going to combine like terms to get 2y squared. We want to isolate the y squared. So the next thing we need to do is move over the 2. Okay. So y squared is going to equal, we forgot 18 squared. Let's go back and fix that real quick. So this is 18 squared. Okay. This is going to equal 324, which is going to equal 162. All right. And then when we take the square root, we're going to break down that 162, which is 2 and then 4 3s. So each set of 3, remember the twins escape, only one survives. It gives me 1 3 out front and a 2 left inside, and that's where the 9 radical 2 comes from. All right. The second one is a lot easier, okay? This is really the hardest thing I can give you, is I give you the hypotenuse, except there's no radical 2 there. So I have to figure out what I'm multiplying by to become radical 2, become this whole number here, okay? So in the next question, in number 2, all right, you guys can see that I already remember the pattern where they're giving me this is x. So this hypotenuse is 2x, and this long leg across from the 60 is x times radical 3. Okay. Now I already know here that 2x is 36. So this lets me determine x very simply by just dividing by 2. And I get x is equal to 18, and I'm done. Okay, there's the shortcut. All right. For number 13 is like the last question, but now there's a radical involved, so this question becomes a lot easier. Okay, in terms of y, the leg is y over here, which means this leg is y, because remember it's isosceles, and then this hypotenuse is y times radical 2. So since I already can see y is supposed to be, I know that y is equal to 11. Now I'm showing my work, by labeling my triangle with y and y radical 2. So this is how I demonstrate how I know the answer. Okay, this is showing work, justifying, we're good to go. And the next question. Now I'm looking for y, but I need to call this side something. This is the first side I need. So I'm going to use another variable here. We're going to call it x. Okay, so if I can figure out what this side is, then I can tell you this. Okay, remember the pattern, x, this long leg is x radical 3, and the hypotenuse is 2x. So if 2x is 14, that means x is 7, and that y is equal to 7 radical 3. Okay, so once again, I labeled and what my sides were. I figured out my 30-degree angle side, the side across from the 30, the short leg, and then I was able to state my answer. Okay, and same thing on the next one. I want to know what this side is, but I need to call this something. I always have to start across from the smallest angle. So we're going to call this x. This is x. Remember the pattern, 2 equal sides. So I multiply by radical 2. X radical 2. So if x is 3.2, that means y is equal to 3.2, and we just multiply that times radical 2. All right. Number 6, same thing. Figuring y. I'm going to label my sides. Always start with the shortest one. So that's x. The hypotenuse is 2x. And this becomes, not 2, x times the square root of 3. So this easily tells us that x is equal to 4. And that means that y is equal to 2 times 4, which is 8. That's it. On to the next page. Okay, for the next one, we want to determine whether the triangles are 45, 45, 90. So these sets of numbers follow the pattern for a 45, 45, 90 or a 30, 60, 90. So remember the pattern for 45, 45, 90. It's got to be this x, the same side again, and then that side times radical 2. And for 30, 60, 90, it has to be a given side. The next side has to be times radical 3. And then the last side has to be double whatever the first one is. Okay? Remember, this side is always the smallest. So for the next one I see a 40. All right? And then if I'm following the pattern, this is x, this is 2x. However, this is not x radical 3. Okay? So that means that it doesn't follow the pattern, and this is neither. All right? Same thing on the next one. This is supposed to be x, 2x, and x radical 3. However, this is not equal to x radical 3. It's 2, and this is also neither. All right, the last one is supposed to follow, if we got the radical 2, it's supposed to be x, x, and x radical 2, or it's going to be, right, x, 2x, which doesn't fit here. So the question is 6 radical 2 times another radical 2 equal to 12? Does it equal 12? I don't know. Let's see. Radical 2 times radical 2. So I'm going to do that first. Okay. And that's like squaring it. So radical 2 times radical 2, we talked about this earlier, is equal to 2. So this is really 6 times 2. This is really the square root of 4, which is 2, which equals 12. And that is it. So this does follow the pattern. Okay. So this is a 45, 45, 90-degree triangle. Number 10, square is the length of side of 95. Now, not drawn to scale here, but these are both 95, and I draw this diagonal in. We want to know what the length of this hypotenuse is. All right, that's the diagonal. Another word for diagonal is the hypotenuse. Now, in general, whenever we cut the diagonal through the square here, it cuts these two angles in half. So these angles are both going to be 45 degrees. All right. So the pattern for this type of triangle is supposed to be x, x, and x radical 2. So now I know that the diagonal has a length of 40, 95, sorry, radical 2. Now there's a second option, which is I can use Pythagorean theorem. So x squared plus, I shouldn't say x squared, right? A squared plus b squared equals c squared. Now a and b are the legs here, okay? So that's going to be 95. So 95 squared plus 95 squared is equal to c squared. Now when I add all these lovely things together, this is 18,050. 18,050. All right, and then I'm going to take the square root. Now, if you really break this down, it actually pulls apart kind of nicely. It's 2, right? And 9025, okay? And this was really just 95 times 95. So you can kind of see where this is going. So in the square root here, I get 95, 95, and 2. I pull up my set, one number comes out, and I get 95 radical 2. Now normally I would say we'd keep going on this, right? We'd go 19 and 5, okay? Same thing, 19 and 5. But we're just going to pull out a 19 and a 5, which is 95, and then leave with the 2 inside. So either way you do it, it's up to you. Whether you want your radical to be 2 times 19 times 19 times 5 times 5, and then pull out your sets, you're still going to get 95 radical 2. All right, this time we're switching it up and we're doing the diagonal with a length of 13, okay? So this now has a length of 13 in my square. These two, remember, are the same. And in order to figure out what they are, we're going to call these x. Now, in order for this to be x and x, this needs to be x radical 2. So if you don't remember how to do your equation, you can just use Pythagorean theorem. X squared plus x squared is equal to 13 squared. This becomes 2x squared. This is 169. We'll divide by 2, and then we have to take the square root. 69 divided by 2, 84.5. And then you can't leave this in simplest radical form. It kind of is right there. So that's why they ask us to the nearest centimeter. And we get 9 centimeters. Now, if we were doing our normal way that we talked about before, I would want x radical 2 to equal 13. I will divide by radical 2. And since we're just rounding, I don't actually need to rationalize. So I can just type this right on my calculator. 13 divided by the square root of 2. And it gives me the same answer, okay? You guys can check it on your own if you want. It's the same 9.192388155. So we're still getting the same answer either way. Okay, find the area of each figure. Now, we can really think of this figure as a triangle, okay, and a rectangle. So what we really need to do is figure out what the length of this side is right here, because I need it for the height of the triangle and also the height or length or width, whatever you want to call it, for the rectangle. So my rectangle has an area of, we'll say, base times height, okay? And we're going to do area. We'll draw a little rectangle so we know what we're talking about. The base is 30. However, we don't know what the height is. And my area of a triangle is 1/2 base times height. And I don't have either for this one, okay? So what we need to remember is that I actually do have a 30, 60, 90 right triangle here with a side of 12. So remember the deal. We label the side across from the third degree angle first as x. Okay, the hypotenuse is 2x, and the long leg is x radical 3. So this tells me that if this is 12, the side is 6, and the height then is 6 radical 3. Okay? So here we go. We're going to plug in now. So this height becomes 6 radical 3, which means the area of my rectangle, 30 times 6 is 180 times radical 3. And I'm going to leave it like that because it says simplest radical form. And my triangle becomes 1/2 base 6 times 6 radical 3. Now I'm going to take half of 6 first here and get 3, and then do 3 times 6, which is 18 radical 3. And then for the total area, I'm going to add those together. So when I add radicals, it's just like adding x's, okay, or variables. As long as the radicands are the same, I can add them together. And I add the 180 and 18 to get 198, and then the radical 3. And that is my total area. Okay. Same type of thing on the next one. So I don't know that this is a square, okay? But I do know it is at least a rectangle because I don't know the sides are equal. Once again, we get a triangle, all right? Now, because it's a right triangle, when I do my formula, 1/2 base times height for the area of my triangle, remember that the base and the height are really just the legs. So for a right triangle, the formula is actually 1/2 leg times leg. Okay? So same thing we did before. If this is 30 degrees, that means that the side across is x. This side becomes x radical 3 across from the 60-degree angle, and then the hypotenuse is 2x. So that tells us that this x is 6, and this side is 6 radical 3 again. Okay, so the area of the triangle is 1/2 the leg, which one of them is 6, and the other one is 6 radical 3. We've already done this on the last question. We know that this is 18 radical 3. And then the area of my square, or rectangle in this case, is base times height, which is 6 times 9. And so this is 54. And so my total area is 54 plus 18 radical 3. Now, because this does not have a radical on it, I cannot add these together. Okay, they're not like terms. All right, so this is my final answer. That's it, guys. Okay, so we'll do a couple more of these on Monday. You guys have a great weekend. Remember, homework is the law of cosines worksheet. I'll see you guys later.